Okay. As I will continue solving exercises. Exercise 8 gives the following for elements RTX and D. Write with justification the electron configuration of an element T has one valence electron on the energy level M. Since we have an energy level M, we have K, L, M, and N. And we have one electron or one valence electron on energy level M, so the other energy will be complete. K by 2, L with 8, M with 8. This is the electron configuration of element T. Element R has 31 in nucleon. Nucleon represents the mass number, and 16 of no charge, and these are neutrons. Isn't number of neutrons is equal to 16 since neutrons has no charge. Mass number A is equal to 31 since A represents the number of a nucleon. To write the electron configuration, we must the atomic number A is equal to Z plus N, and Z is equal to A minus N. Then Z equal 31 minus 16 is equal to 15. Since atom is neutral, this means number of electrons equal number of protons is equal to Z. So is equal number of electrons is equal to 15. Then the electron configuration is K2 L8 M5 M5. So the electron configuration is K2L8 M5. This is the electron configuration of the second element R. The third element X. Okay, element X is located between carbon and oxygen. Since it's located between carbon and oxygen, then the atomic number of element X is equal to 7, since it is greater than 6 and less than to 8. So atom X has 7 electrons. So 7 electrons, the electron configuration would be K2L5. For the fourth element D has same row as AR in column as carbon. Is an carbon in part 3, carbon has an atomic number is equal to 6. We write the electron configuration of carbon 6 since it has 6 electrons. The electron configuration is K2L4. Then carbon has 4 valence electron. The argon AR 18 has an electron configuration K2L8 M8. D has same row as AR. Then in D, a row is equal to 3, while column is equal to 14 as carbon. Then we have here row 3 and the 3 occupied energy level. which are K, L, and M. Then the electron configuration of D is K2, L8, M14. It has a valence electron 4 as carbon. Then the electron configuration is K2, L8, M4 for the element D, according to the given same row as AR. AR and the row is equal to 3, and has the same column as carbon. Carbon has a 4 valence electron, mean it is column 14. So we obtain an electron configuration K2L8 and 4. We continue to another exercise. Exercise 9, talking about the some elements in fruits. And the adjacent document 1 shows the distribution of electrons, our arrangement of electrons in potassium element. We will answer the following question. Part 1, according to the document 1, indicate the number of electrons. If we count the number of electrons, 2, 4, 6, 8, 10, 12, 16, and 19. We have number of electrons is equal to 19 according to document 1. Deduce the atomic number in a neutral atom. In a neutral atom, number of electrons equal number of protons equal to atomic number, then it is equal to 19. Part 1.3, write the electron configuration of the element. Since we have 19 electrons in potassium, the electron configuration will as K2, L8, M8. We have 18 and N1. The lowest dot symbol of potassium. Potassium has a symbol K, and we have one valence electron and represented by a 1 dot. The nucleus of potassium containing 20 uncharged particles. Number of uncharged particles, which is the number of electrons. The number of uncharged particles in potassium is the neutrons, or are the neutrons. What does this particle represent? They represent number of neutrons number, or represents the neutrons particle. Write the symbolic representation in any element are represented by X, E to Z. Z, the atomic number. We write what is meant by Z, because Z is atomic number, which is equal to 19 as we proved before. A is known as mass number, and to calculate the mass number, A is equal to Z plus N. Z plus N, Z is equal to 19, N is equal to 20. We have 20, so the mass number is equal to 39. So the symbolic representation of potassium is K1939. Continuing the exercise, fluorine atom gain 1 electron. Fluorine gain 1 electron to form a fluoride ion. It helps in protection of these from decay. Only the electrons of a fluoride ion isn't. This is the electron configuration of a fluoride ion K2L8. Translate the formation of a fluoride ion into an equation. Then fluorine gain 1 electron to change into fluoride fluoride إذا since it gain it would become negative ion. Any elements or any atom gain electron, it change into negative ion. Since we have one electron, we have -1 or minus. This is the symbol of a fluorine atom, and this is the symbol of fluoride ion. Choose among the following the correct electron configuration in the fluoride. Alpha. This is an incorrect question. In fluorine atom. This is the correct one. إذن fluorine gain one electron to become a fluoride ion, and as we know, the fluoride ion has an electron configuration K2L8. Number of electrons in the ion or in the fluoride ion is equal to 10 electron after gaining 10 electrons or after gaining 1 electron. So the fluorine atom has 10 electron minus 1 to retain what are the number of electrons in the fluorine atom. In the fluorine atom, before gaining electron, we subtract 1, which is equal to 9 electrons. So the electron configuration will be K2L7. This is the correct electron configuration of fluorine. So the correct answer is A. Specify the position of a fluorine atom in the periodic table. Position of in the periodic table, row and column. Row is equal to fluorine element. We have 2 energy level. Row 2, we have 2 energy level, K and L. Column 17, since we have 7 valence electron in the electron configuration or in the outer energy level.